For problem number 1, we have monthly temperatures for Baltimore, Maryland, and they ask for the amplitude, and then they ask for the vertical shift, and then they ask for the period, but we're going to do it in the opposite order because the period is the easiest one to find. The period is equal to 12 because it is 12 months. Now, the vertical shift, I'm looking for the minimum number and the maximum number. So the minimum number is 32 in January, and the maximum is going to be 77 degrees in July. And when I take the average of those two, we get the vertical shift. And so if you check that on your calculator, you should get the answer of 54.5. For the amplitude, we're just going to take our maximum minus the answer that we got in the vertical shift. Which is 22.5. Then letter D, they're asking for us to make a sinusoidal function that models the monthly behavior using t equals 1 in January. So having done that, we are going to do y equals, and we're going to use cosine because we're going to use the maximum. And so I'm going to have 22.5 here plus 54.5 over here, and then I need to get the middle. So 2 pi divided by k is equal to 12, which means 2 pi is equal to 12k. Divide both sides by 12, and k is equal to pi over 6. Now the phase shift, since the highest month for temperature is July, we are going to have a phase shift of 7. So I'm going to do pi over 6 times 7 plus c equals 0. Well, 7 times pi over 6 is 7 pi over 6, which means c equals negative 7 pi over 6. And there's our answer for the equation. Alright, so now for letter E. According to my model, what is the average temperature for July? So July is month number 7. So we're going to do 22.5. Remember that your calculator should be in radians. And so the question is, what happens when we plug this into our calculator? And we get the answer of 77, which is exactly the temperature that we had on the chart. For letter F, what is the temperature for December? So December is obviously month number 12. So we got pi over 6 times 12 minus 7 pi over 6 plus 54.5 and in December we get the temperature of 35.01, which is close to 37. We're just off by a couple of degrees. For problem number 2, a buoy is bobbing up and down in the water, waves moving past from the highest point to the lowest point, back to the highest point every 10 seconds. The distance between the highest point and the lowest point is 3 feet. What is the amplitude of the sinus and the period? So in A, we're looking for the amplitude, and B, we're looking for the period, which is pretty easy because the period is every 10 seconds, because that is how long it takes to get to the highest point. So the question is, what is the amplitude? Well, the distance between the highest point and the lowest point is 3. But that is not the amplitude, because if I cut this in half, that's 1.5 and that's 1.5, so my amplitude is 1.5. Now they're asking us to do this with a sinusoidal curve where we are starting at the highest point. So they're telling us that we're starting at the highest point. Now what they haven't told us is what is the vertical shift. So the question is, how can we do this? And so what we're going to say is the vertical shift is going to be equal to 0, which means that we are basically saying that if it's calm, this is what the surface would look like. So going back to letter C, we're going to say y equals 1.5 cosine, because we're starting at the highest point, and the 1.5 is positive because we're at the highest point, not the lowest point. And then we have to do 2 pi divided by k equals 10. Multiply both sides by k, divide by 10, and we wind up with k equaling pi over 5. Alright, so I should probably change that to a theta, even though it really should be a t, because we're talking about time here. In part D, so the amplitude was A, the period was B, and the equation was C, it says to find the height at 2 seconds. So we plug in 1.5 cosine pi over 5 times 2, and that turns out to be 0.463, and we're talking about feet above the surface. And then letter E, if we do t equals 6, we get 1.5 cosine pi over 5 times 6, which turns out to be negative 1.2 feet, which is 1.2 feet below the surface, where if it was perfectly calm. Alright, that is it. I suggest that you start working on your 6-6 homework, because you have the calculators here. I'm going to show you one thing if you want to start working, if you like the way that this works. If you want to figure out a different way to do the problem number 1, I'm going to show that right now. So hit stat and edit, And in L1, you'll have all of the months, so dot 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 down to 12. And in L2, you have the temperatures, which are 32, 35, 44, dot 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 dot, all the way down to 37. So put that in your calculator, pause the video if you need to, and then we'll talk about how to get the equation. Alright, once you have those all in there, hit second mode to quit, hit stat, calc, and then you want to go down to the sine regression, which is letter C. So stat, math, C, and we're using L1 and L2, and hit enter. And you should have had something that comes out like this. So this is telling me y equals 22.4, because A is the amplitude, sine, let me rewrite this on another page. So if you don't have this, you should hopefully, either I made a small error, you made a small error, but the equation would turn out to be y equals, the amplitude is 22.4, so these answers are going to be slightly different from ours. They're using sine instead of cosine, and we're going to use 0.509x minus 2.1, not 0.21, 2.1 plus 54.66. So that's another way to get the equation. It's not perfect because it doesn't have the right period, but it goes closer to the points than my original equation. You can either use the original way that we did it or the calculator way. Email me with any questions.